Assalamualaikum. My name is Alif and my group member is Zul, Farhan, Farid, Iqbal and Amirul. Today we want to present about experiment 3, measuring gravitational acceleration. In this experiment, we have two objectives. Objective number one, to investigate the functional relationship between height of fall and falling time. Objective number two, to determine the acceleration due to gravity by studying the motion of a freely falling body.
Okay, so next I am going to tell you about the theory of this experiment. The theory is the body of mass moves linearly if it is propelled out of rest in the gravitational field with constant gravitational force. We can obtain the following results by applying the coordinate system so that the x-axis represents the direction of motion and then solving the related one-dimensional equation of motion. From the regression line of the data, we can calculate the gravitational acceleration because the slope is equal to half of a gram according to equation.
The apparatus that are needed for this experiment is falling sphere apparatus consisting of release unit. The second one is impact swift. The third one is digital counter. Apparatus number 4 is 4 decades. Number 5, support base. Number 6, right angle clamp. Number 7, plate holder. Number 8, meter scale. Number 9, supporting rod. Number 10, connecting rod. And lastly, ball bearing. Okay, for the first procedure, the apparatus was set up and electricity conducting sphere was gripped in the release mechanism which closed the start circuit. Okay, for the second procedure, the pen was adjusted using the adjusting screw under the error switch was such a way that a downward motion of a few tenths of a millimeter closed the stop circuit. The pen was raised by hand after each single measurement. Third procedure, for the effective determination of the height of fall, using the marking on the release mechanism, the radius of the sphere must be taken into account. The aerodynamic drag of the sphere can be disregarded.
The next part is results of experiment. In the table below, we can see the result of height of fall and falling time. We can conclude from the table that when height of fall increase, the falling time will also increase. This shows that the relation between height of fall with falling time is directly proportional. This is because when height of fall increase, the falling time taken will be also increase. The falling time is taken for 3 times to get an average result which is more accurate.
Next is analysis part. So for the first analysis, from the data that we have collected, we had plot graph for height of fall as a function of falling time. We also plot graph for height of fall as a function of the square of falling time. For the second analysis, we should using the height of fall as a function of the square of falling time graph to determine the gradient of the graph and calculate W of G. As you can see there, that is how we determine the gradient of the graph and calculate W of G. Okay, for the third analysis, we need to calculate value of asymptotic of G. And this is how we calculate value of asymptotic of G. Okay, for the analysis number 4, this is how we calculate the percent error in this experiment value.
So discussion for this experiment, students have expected that if the height increased, then the time will be increased too. Because students consider the graph height versus time will be directly proportional. Compared with expected, student results have achieved the expectation because student expected the graph will be directly proportional, like what student get in the experimental data. However, this experiment still have the weakness that we need to improve, like a ball bearing position when student using falling sphere apparatus consisting of release unit and negligence of student setting the time when using digital counter. This weakness can be resolved if student more focused and carefully when conducting the experiment. The last part of the experiment is the conclusion. The goal of this experiment was to assist in investigate the functional group between a height of fall and falling time. This experiment also to determine the acceleration due to gravity, g, by studying the motion of a freely falling body. The determination of relationship between falling time and height can legitimately be accomplished throughout this experiment. The result of experiment show that relationship between falling time and height is directly proportional in order to get accurate result from this experiment. The times need to be determined very accurately. In the event that the experiment committed even a single error, the result of this experiment will be affected. Because of this, it is extremely important to make sure the digital counter is zero before we release the ball bearing.